Welcome to the Depth Dive. Today, we're plunging into really a revolutionary moment in software development. For decades, the basic way we build software has been pretty stable, right? But now, things are just shifting incredibly fast, like faster than we've seen in generations.
Yeah.
It's this fundamental transformation. And if you're just entering the industry, wow, what a time. It's unique. It's exciting. We're really talking about the nature of software changing.
Absolutely. And our mission today for this deep dive is really to unpack that. We're going to look at it through three sort of distinct programming paradigms: software 1.0, 2.0, and the newest one, 3.0.
Okay.
And we're drawing a lot from a really insightful talk by Andrej Karpathy, former AI director at Tesla. He's watched this whole evolution unfold because it's a great map, really.
Okay, let's get into it then.
Yeah.
Software 1.0. This is the stuff most people probably think of first, right?
The classic stuff.
Yeah, the handwritten code, your C++A, your Python, where developers sit down and write out every single instruction, telling the computer exactly what to do.
Every step.
It's the foundation, sure, but the key thing is it's all explicit human instructions. Every decision path, coded by hand, painstakingly. You know those cool map of GitHub visuals?
Oh, yeah, massive.
That's basically a picture of billions of lines of software 1.0.
Exactly. And then comes software 2.0. This is where neural networks really change the game. The big shift, the profound thing, is you stop explicitly coding the rules.
Right.
Instead, you're training systems. You give them massive data sets, run optimizers, and they infer the rules. They create the neural nets, weights these incredibly complex parameters that define how it behaves.
So it's less how to and more figure it out from this data.
Precisely.
Yeah.
What to do based on data. And you see platforms like Hugging Face, Model Atlas, they're kind of the GitHub for this 2.0 world, full of trained models.
Okay.
You might have seen that graphic, the giant circle showing the parameters for the Flux image generator. That's software 2.0 code, in a sense.
Right, the model itself.
Yeah. And Karpathy had this great example from Tesla, the autopilot system. Started with lots of software 1.0, right? Loads of C++ true. But as the neural nets got better and better, they literally ate through that C++ code. They just took over functionality, replaced it.
Wow, okay. The AI literally consuming the old code, that's vivid.
It is.
So if software 2.0 is about training these networks, what happens when the networks themselves become programmable? That feels like another huge jump. Is that 3.0?
That is software 3.0, exactly. And it's fundamental because it really creates, as Karpathy calls it, a new kind of computer.
A new kind of computer. How so?
Well, it's pretty astonishing. Because now the programs you write, they're just prompts written in natural language, like English.
Wait, just English? Not Python, not shutting?
Just English prompts to program the LLM, the large language model. Think about sentiment classification, 1.0. You write Python code, 2.0. Maybe train a specific neural net. But now, software 3.0, you just give the LLM an English prompt. Classify this text, positive or negative. Done.
That is wild. So the implication is huge. We're programming computers in our own language.
It's massive. Karpathy tweeted about it, went totally viral. And, for good reason. It changes everything. If you're coming into the industry now, you kind of need to speak all three languages, 1.0, 2.0, and 3.0. Understand the pros, the cons, how they fit together.
Programming in English. Okay, that's a radical idea. To really get a handle on it, what this new kind of computer means, we need some analogies, right? The first big one you mentioned is AI is the new electricity. That frames LLMs as utilities.
Yeah, it's a powerful starting point. Look at the big labs, OpenAI, Google with Gemini, Anthropic. They're pouring in capital, CapEx, right?
Yeah.
Huge investments to train these LLMs.
Like building the power plants in the grid.
Exactly like building the grid.
Yeah.
Then they have ongoing costs, OPEX, to serve that intelligence through APIs, usually metered access, just like electricity.
Pay for what you use.
Right. And you see these very utility-like demands emerging. Low latency, high uptime, consistent quality. People depend on it now. There are even tools like OpenRouter, kind of like an LLM transfer switch.
So you can swap providers if one goes down or gets expensive.
Precisely. And it's funny, when a major LLM does go down now, and we've seen this, it feels like an intelligence brownout.
Huh. The planet just gets dumber.
I love that line. And it felt like that a few weeks back when one had an outage. Half my tools just stopped working.
Yeah.
Really brings home the utility point.
It really does.
The source also mentioned a fabs analogy, like chip making, because of the huge cost and the secret R&D.
Yeah, it touches on that, the big capital, the centralized secrets. But it also calls it a bit muddy.
Why muddy?
Because software is just so malleable. It's not like a physical chip fab with tangible, defensible hardware secrets. It's easier to copy or recreate software eventually.
Ah, okay. Less of a physical mode. So what's the strongest analogy then?
The source argues, and I think it makes sense, that the best parallel is actually operating systems. Okay, like Windows or Mac OS.
Exactly. LLMs aren't simple commodities like electricity from a tap. They're these incredibly complex software ecosystems.
Yeah.
And you see the same dynamics playing out. You've got your closed-source giants like Windows, Mac OS.
GPT-4, Claude 3.
Right. And then you have your open-source alternatives like the whole Llama ecosystem, which is very much like Linux for LLMs.
Interesting. And the LLM itself is like the processor.
Yeah, the LLM is sort of the CPU equivalent. And its context window, how much information it can hold at once, that's like its memory or RAM, it orchestrates the problem solving.
Okay.
Think about apps. Like VS Code runs on Windows, Linux, Mac, right? An LLM app, say Cursor, which we'll talk about later, it can run using GPT or Claude or Gemini. It's often just a drop-down menu choice in the app.
That OS comparison really clicks, especially with Llama as Linux. But hang on, aren't LLMs, well, unreliable sometimes?
Yeah.
They hallucinate, right? That doesn't feel very OS-like. OSs need to be deterministic.
That's a really fair point. And yeah, that's a crucial difference. They are probabilistic, not deterministic, like Windows. That's why it's an analogy, not a perfect one-to-one map.
Okay.
The OS analogy works well for the complexity, the ecosystem, how it manages tasks. But yeah, that probabilistic nature is key. And actually, that ties into another parallel. We're kind of in the 1960s era of computing for LLMs.
The 1960s, how so?
Because the compute is still so expensive, it forces the LLMs to be centralized, mainly in the cloud. We're all basically thin clients connecting over the network using time sharing on these massive machines.
Like the old mainframe days.
Exactly. We haven't really had the personal computing revolution for LLMs yet. I mean, you see hints with things like running models on Mac Minis, but we're not there yet.
Right. And just interacting via text feels very terminal-like.
It does, like talking to an old command line. We haven't invented the standard GUI for LLMs yet.
So OS-like complexity, but 1960s access, that's a weird mix. And it also highlights something else really unusual, doesn't it? The way this tech is spreading.
Oh, completely. It's flipped the script.
Usually tech starts with governments, military, big corporations, then trickles down, right? Electricity, the internet.
Yeah, the classic diffusion pattern.
Yeah.
Military ballistics, corporate mainframes. But LLMs, it's the complete opposite.
It started with consumers.
Totally. It's about helping me boil an egg, like Karpathy said. Not complex corporate workflows. Initially, ChatGPT was just beamed down to everyone's computers, like instantly. Billions of people overnight.
ChatShip beamed down. That's quite an image.
Consumers jumped on it first. Corporations, governments, they're actually lagging behind in figuring out how to adopt it systematically. It's unprecedented.
That mass adoption really forces you to think of the psychology of these things. Viewing them as stochastic simulations of people makes sense, given they learn from all that internet text.
It does. They pick up on human-like patterns, and they have these incredible superpowers. Their knowledge is encyclopedic. Their memory, vast, way beyond any single human.
Like that Rain Man analogy Karpathy used.
It's exactly like Rain Man. Almost perfect recall of anything in their training data. Just pull facts out of nowhere.
But this is the big but. They have these weird cognitive deficits, too.
Break one?
Hallucinations, obviously. Making stuff up. And they don't seem to really know what they know, right? Lack of self-knowledge.
Yeah, it leads to what's called jagged intelligence. It's bizarre. They can do superhuman things in one area, then fail spectacularly at something basic. Like insisting 9.11 is greater than 9.9. Or spelling strawberry with 2 R's. Stuff no human would trip up on like that. It makes building reliable systems on top of them tricky.
Definitely. How can you trust it if it can't spell strawberry?
Right. And there's this other issue, kind of like anterograde amnesia.
Amnesia.
Yeah, unlike us, they don't really consolidate knowledge or gain expertise over time from interactions. Their core brain, the weights, is fixed after training. In the context window, their short-term memory basically gets wiped clean constantly.
So every conversation starts fresh almost.
Pretty much. Think Memento or 50 First Dates, that kind of constant reset. Plus, you have security worries. They can be gullible, fall for prompt injection attacks, leak data.
So it's this weird mix, a superhuman entity that also has these fundamental cognitive flaws and memory issues.
Exactly. A superhuman thing with a bunch of issues.
The challenge then is, Okay, how do we actually work with this? How do you program it effectively, get the benefits without getting burned by the flaws?
That is the million-dollar question.
Yep.
And just talking to it directly, like in ChatGPT, often isn't the best way for complex, reliable tasks. The real opportunity seems to be in building partial autonomy apps.
Partial autonomy apps, like what?
Cursor's a great example for coding.
Yeah.
It blends a familiar human interface, like a code editor, with LLM integration working behind the scenes on bigger tasks.
So it's not just the LLM.
No, the LLM's part of it. It manages the context, calls different types of models, embedding models to understand code, meaning chat models for generation, diff models to show changes. But crucially, it needs application-specific GUIs.
GUIs, graphical interfaces. Why are they so important?
For auditing, these systems are fallible. You need to check their work. Seeing code changes visually like red and green diffs, that's super fast for your brain to process, much faster than reading pages of generated text trying to spot errors.
Ah, makes sense. The GUI speeds up the human verification step.
Exactly. And Cursor also has this autonomy slider. You can dial it up or down. Maybe you just want simple code completion, or maybe you want it to try and refactor a whole chunk of code. You control the level of AI involvement.
Okay, I see. And Perplexity for search does something similar, right?
Very similar. It packages info, uses multiple LLMs, has a GUI that even shows sources for auditing, and lets you choose between a quick answer or a deeper research dive with its own slider. It's augmenting the human, keeping them in control.
So the core idea is this: generation verification loop.
That's the key principle. The AI generates something, the human verifies it. The goal of these apps is to make that loop fast. GUIs are critical because our visual processing is way faster than reading dense text. It's a highway to your brain.
Right. Verify quickly, iterate quickly.
And you need to keep the AI on the leash. Don't ask for a massive 10,000-line code change that takes forever to verify, even if the AI can generate it instantly. Small, incremental steps are much more effective.
Easier to check.
Much easier. And concrete, specific prompts work better too. Less ambiguity means higher chance of success, faster verification.
You know, this sounds a lot like the journey with self-driving cars at Tesla.
How so?
Well, that was also partial autonomy, right? With GUIs showing what the car sees and autonomy sliders for different levels of assistance. And Karpathy mentioned that perfect demo back in 2013.
Ah, yes, making it look like full autonomy was just around the corner.
Exactly. But here we are, what, 12 years later? And it's still not fully solved. It shows that this year of agents idea, it's probably more like the decade of agents.
That's a really insightful parallel, the
Right.
decade of agents.
Humans have to stay in the loop. That slider is going to be important for a long, long time.
It really grounds the hype. And it fits perfectly with Karpathy's Iron Man suit analogy.
Right, the suit. It's both an augmentation and an agent.
Yeah. He argues we should focus less on building fully autonomous Iron Man robots right now and more on building Iron Man suits, products that augment human skills using custom GUIs, that fast generation verification loop, and the autonomy slider. Let the autonomy grow over time.
Build the suit first, let the robot emerge later. Makes sense.
Okay.
So that covers how we interact with them, but there's another angle. The fact that programming is now in English means, well, almost everyone is a programmer now.
Kinda, yeah. It lowers the barrier dramatically.
Yeah.
You don't necessarily need those 5-10 years of deep coding study to start creating things, which led to that meme, vibe coding.
Vibe coding. What's that?
It's just this phenomenon of people, often without formal training, just experimenting, telling the LLM what they want in English, tweaking the vibe until it produces something useful, like custom software on the fly.
Huh.
Karpathy showed this really wholesome video of kids doing it. He sees it as a potential gateway drug to software development. Very optimistic.
That's cool. Did he try it himself?
He did. Built a basic iOS app in a day, apparently, without knowing Swift. And he made this little app called Menugenen for restaurants to generate menu descriptions.
Menugenen. Okay, how did that go?
Well, the vibe coding part, the actual LLM interaction to generate descriptions, that was apparently easy, fun even.
But there's always a but.
But making it real authentication, payments, domain names, deployment, all the DevOps stuff that was suddenly really hard, super frustrating for him.
Oh, the nuts and bolts.
Yeah. He found it absurd that the super intelligent computer could write the core logic, then had to give him, the human, step-by-step instructions like, click this button or choose that option to actually deploy it.
Huh. Like the AI did the smart part and left him the tedious bits.
Exactly, which raises a fascinating question.
Can we just build for the agents?
Precisely. Agents are this completely new thing, right? These sort of human-like computer intelligences, people's spirits almost.
Yeah.
They need to interact with our existing digital world.
Yeah.
How do we make it easier for them?
So how do we do that? Build for agents.
Well, think about robots.txt. That simple file tells web crawlers what they can and can't access.
Right.
We could have something similar, like LLM.txt. Just a simple markdown file on a website that tells an LLM directly, here's what this domain is about, here's the key info. Much easier for the LLM than trying to parse complex, messy HTML designed for humans.
Like leaving clear instructions for the new digital resident.
Exactly. And documentation needs a rethink, too. Some companies, like Vercel and Stripe, are already offering docs in clean markdown.
Easier for LLMs to read.
Much easier. But the content needs to change, too. Instead of docs saying, click this button, they need to provide the equivalent curl command.
A command line instruction the agent can actually execute itself.
Yes. So the agent doesn't need a human to translate click here into an action. Anthropic's working on something called a model context protocol, too. Another way to talk directly to models.
Okay. And there are tools popping up.
Yeah, tools like Gettingist, it just grabs all the code from a GitHub repo and swooshes it into one big text file ready for an LLM to read. Or DeepWiki, which analyzes a repo and tries to automatically generate documentation for LLMs.
So it's about meeting them halfway, making our existing infrastructure more agent-friendly.
That's the idea. Meet them halfway. Make the information structured and accessible for them, even while they're still learning to navigate the visual, human-centric web.
Right. Okay, so wrapping this up, it really is an incredible time.
It's amazing. You've got this massive code rewrite happening across these three paradigms. You've got LLMs as these complex new operating systems, but still in their 60s time-sharing phase. They're powerful but fallible people spirits that we need new ways to work with. Partial autonomy apps are key, focusing on those GUIs, the fast verification loop, the autonomy slider.
And starting to build for the agents themselves.
Definitely. Adapting our infrastructure.
It all comes back to that Iron Man suit, doesn't it? Augmentation first, with that slider ready to move towards more autonomy.
That feels like the most practical and powerful approach right now.
So the final thought for you, the listener. Over the next decade, we're collectively going to be pushing that autonomy slider bit by bit, from left to right. The question is, what will you build as we all figure out what that journey looks like? How will you use these new paradigms?